So this video is going to be like a challenge to me because I'm going to explain the 7 functions, give an overview of it. So I'm going to give the domain, range, how to draw it, etc. So starting with a straight line. So if I put a straight line over here and the equation is, let's say, y is equals to, okay, mind that, just mind that. So the equation is y is equals to x plus 1. Now what does the 1 say? The 1 is a c value. The 1 says where it hits the y-intercept, which is this. So in this case, it says 1, that means it hits the y-intercept here with 1. To find the x-intercept, we make y 0. So 0 is equal to x plus 1. Then you solve for x, you'll get x to be minus 1. Another way to find the x-intercept, the original graph of the straight line is y is equal to x. And you know y is equal to x goes straight through this line over here. So if it's plus 1, that means it moved 1 unit to the left, and therefore you got this graph over there. Alright, now what is the domain and range? So the domain for this straight line will always, no matter be if there's no restriction, minus infinity to positive infinity. Alright, do not include infinity signs. The range will be exactly the same. Minus infinity to infinity. Do not include the infinities. We do not include infinities because they're not included, like they are numbers that go on. So this is the domain and range for the straight line. Now let's go to the parabola. Now the parabola looks something like this, where it looks like this. Now if I give you this equation of this parabola, which is y is equals to x squared, to find whether it's a parabola, this will always be squared. So the exponent will be squared, and the base will be an x, which will be unknown. Now what is the domain of this? Well, the domain will be minus infinity to infinity, right? Because if you look at it carefully, it goes in all the x values over here. But whenever you do a parabola, the range becomes basically limited, right? Because think about it. This over here, it's starting over here and going to infinity. So it'll be from the y value over here, which in this case, now I never drew it to scale over here, but it's always to touch the origin. So this is actually touching, so 0 and 0. So that means y must be between 0 and positive infinity, because it goes out to positive infinity. Now, what if I had the parabola to be, let's say, x squared plus 1. Now x squared plus 1 is something called a vertical shift. So basically it moves 1 unit up. So the graph will look something like this. So you're going to get a graph and it's going to go like this. Now what plus 1 means? It means where it hits the y-intercept. So in this case we know that that is 1. Now when we doing this, always take note of the range. For the x domain, it will be always x is an element of all real numbers. But for this case, the domain will change. So the domain will be, it'll be from, so because this coordinate here is 0, because x is 0 and it's 1, basically the range will be from 1 to positive infinity. So that's how the range changes with the parabola, so you must take note of that. Remember, parabolas can also have y is equals to, let's say, x squared plus 2x plus 1. It can also be like that, right? To draw this, you know 1 means it hits the y-intercept at 1, but you need to know the turning point. So to work at the turning point is minus b over 2a. So that is minus 2. So this is the b and this is the a. So the a is 1, you can't see it. So it's minus 2 over 1, that's minus 2. So when x is minus 2. So when x is minus 2 is somewhere over here. But you need a y. So put minus 2 in the equation. Minus 2 to the power of 2, that's 4. 4 plus minus 4, it's 0 plus 1. So it's up by 1 over here. So it's minus 2 and 1. So at the coordinates minus 2 and 1. Now remember, this is another new parabola which I'm creating with this one, right? So just ignore this. Or we can erase it. Okay, I can't do that now. But minus 2 and 1. So the parabola, this will be like the origin, like over here. So it will go like So that's how this new parabola with origin minus 2 and 1 will look like this. So that's how you know. Now note, x in element of real will be domain will be like this. Range, always look at the y value of the turning point. It'll always be like that. Now what if you got a negative parabola, so minus x squared? Instead of smiling, it'll be a unhappy face, so it'll go like this. So the parabola will go like this, right? So it look like an opposite direction face. Now let's look at the exponential function. So the exponential function looks something like this. So let me draw that properly. Okay, so exponential function will look something like, okay, I don't know why it's not drawing, but let's try it last time again. Okay, so exponential function will look something like this. Now let's call this equation, let's see, y is equals to 2 to the power of x. Now to find the y-intercept, which is obviously this, and x is 0. So to find the y-intercept, we make x 0. So 2 to the power of 0 will always be 1. So there you can assume that this is 1. Now, what you must know about exponential function, it has one asymptote. It has an horizontal, wait, why I'm saying that, well, just ignore that, horizontal asymptote, right? Now, what's a horizontal asymptote? It's basically a y asymptote. So for this case, the x-axis or y is equal to 0 over here is the asymptote, meaning it wouldn't cross this, right? So straight away there is a invisible 0 over here. So whatever number is here, this is the y is equals to whatever, which is the asymptote. So in this case, y is equal to 0 is this white line over here. So you can see the graph goes, but it doesn't touch that, right? Now straight away you know what will be the domain. So I don't even have to write it. Domain will be all the numbers. So it'll be from negative infinity to infinity, right? So x element of real, all the numbers. However, the range is what? If you think about it, it's what? So if I were to write down the range, it'll be from 0. So no, actually, yeah, from 0, because that's the asymptote from 0 to positive infinity, right? Now I wouldn't include 0 because at 0 it doesn't touch, and I wouldn't include infinity because you can't touch that. Okay, perfect. Now what if you had, instead of y is equals to 2x, so 2 to the power of x. Okay, so firstly, what you need to know about exponential functions is the fact that when you're doing an exponential function, it can be increasing or decreasing. When we had y is equals to 2 to the power of x, it's increasing. But let's say we had y is equals to a half to the power of x. Now, whenever the base is between 0 and 1, so what I mean is between 0 and 1, if you get like a half, a quarter, it'll always be a decreasing graph. But if you get like y is equal to 2x, so when it's greater than 1, so when x is greater than 1, then it's a increasing graph. Now what I mean by this, you see half to the power of x, the base half is going to be a decreasing graph. So instead of going like this, right, it's going to start over here and go like this. You see, so it's exactly the same as y is equal to 2x. Just instead of going like this and going up, it's going to start up and go down, decreasing. So when it's between 0 and 1, the base, you draw it like this, and obviously the other one, it's increasing, so it goes like this, right? So that's an exponential function. Now what's a log function? A log function is very similar to the exponential function. So let's say the log of x to the base 2. So this function will look like this, right? Now as you can see clearly, it has a vertical asymptote. So vertical asymptote is like an x asymptote. For this case, x is equal to 0, which is over here, is an asymptote. Now you can clearly see that's an asymptote, and it'll always be like that when you're doing logs. But let's say instead of 2, you have, now I remember I told you when it's between, like when it's greater than 1, it's an increasing function, and you can see the log is increasing over here. But what happens if you have between 0 and 1 the base? So y is equals to log a half x. Then what's going to happen, right? This is very interesting. So instead of the graph going like this, it's going to start over here and it's going to increase like this. So you see, so it's exactly the same, just that it starts from the different points, right? So that's what happens when you have half x. Now just looking at this graph over here, this one here, the original y is equals to log 2x. What is the domain? The domain will be x is greater than 0. So it's in between 0 to positive infinity. If you look carefully at this one, see this one? Well, both of them, right? Both of them. The x is over here, x is equals to 0. It doesn't touch this, but it goes all the way there, right? And what will be the range? The range will be from minus infinity to infinity. Because think about it. It's existing all over here. It's going from here, infinity, down, infinity, alright? So anytime you get log, the x is an element, the domain is restricted, right? It's restricted. It's restricted by the asymptote over here, which will be 0. So it'll be from 0 to infinity. It wouldn't include 0. The range, the range will always be y as an element of real. Okay, so yeah. The next one is a hyperbola. So let's say you have y is equals to 1 over x. How do you know it's a hyperbola? It has an x over here in the denominator. Now, to the parabola, you need to know two things. It has two asymptotes. One is an horizontal asymptote and one is a vertical. There's an invisible 0 over here and there's an invisible 0 underneath here, but the numerator. So this 0 is a horizontal asymptote. So meaning that over here, this is going to be an asymptote, right? This one here. And then the vertical asymptote is an x asymptote, so it's 0, so it's this one here. So basically what's going to happen, because this is positive, is going to be like this. So this is how my hyperbola will look. Now let's say if this was a negative, it'll be like this and like this. Now why, you may ask? See over here, all this over here, it's a minus and a minus. Okay, so I did something wrong here. So actually the positive will be from here and here. See this? Because think about it, a minus and a minus is a positive. A plus here, because this is plus and a plus here, will be a plus. So if you got y is equal to 1 over x, you'll draw it like this. If you get y is equal to minus 1 over x, you draw it like this. So it'll be 1 over there and 1 over there. Because this is a minus, all these numbers, this is plus. So minus and plus will give you minus, and minus and plus will give you minus. So whenever you got a negative here, you'll draw it like that, positive like that, like that. If you have 2 over here, right, then your horizontal asymptote, which will be the y value, will be maybe like over here. So now you have to draw a graph along this asymptote, so like this, and then like this, alright? So yeah, it just shifts it basically 2 units up, every value 2 units up. Now another function which I never include is called a square root function. So let's say you got y is equals to root x. It looks something like this. So it'll start over here and go like this. Okay, if it's y is equals to root x plus 1, it means move 1 unit up. So it's going to look like, so instead of starting at 0, it'll start at 1 and go like this. But this is like the overall shape, right? Then also I never include something called a power function. So let's say if you have x, so y is equal to x to the power of 9. It's called a power function because the base is an unknown and then you got a constant exponent over there. So it looks something like that. So that's a power function. Alright, so that's power function, yeah. If you look at the power function, domain is all real numbers, range all real numbers, right? So minus infinity to infinity. Also, I forgot to say the square root function. If you picture it again, it's going to look like this. It'll be, domain will be x is greater than and equal to 0, because every value of here. And the range will be, x will be greater than 0, right? I mean, y will be greater than 0, so 0 to infinity, because it doesn't come over here, because the square root can't be a negative. Now, composite functions, what is f fog? So f-o, so o is basically saying put g in f. So put g in f, so wherever you see x, put g in it. So that will be 2, and now because I got x here, you put whatever this equation is equal to. So that will be 2x squared. And to draw this thing, it'll look like, right. But this could be anything, it can be an exponential, hyperbola, anything they give you. Case, it's a parabola, so y is greater than 0, and x is an element of 0. So piecewise function basically is two functions in two separate domains. So x plus 1 is in the 0 plus, so all the positive region. So x plus 1 basically is like a straight line just like this. And then x squared is in the negative region, so you'll have a parabola like this. So basically the function only exists like to that domain. And that's the functions for in 15 minutes.